Well, welcome to all the SCLAA members and guests to our webinar today, Connected Things, Transforming Supply Chains Using IoT. So my name is Stephen Lakey and I'm a director of the SCLAA, and it's a pleasure to welcome you all here today. For the benefit of guests who may be attending today, an introduction to SCLAA. So SCLAA stands for the Supply Chain and Logistics Association of Australia, and we're Australia's largest association for supply chain professionals. We give value to our members by thought leadership webinars like the one you're watching now, but also face-to-face events. We provide informative breakfast seminars, networking events, site tours to some of the country's leading distribution centres, and our mentoring program is about to kick off next month. We also host the Australian Supply Chain and Logistics Award, which is happening this November. So if you are in supply chain and you're not a member and would like to know more, shortly I'll put the details in the top of the comments box so you can get those. And I'll also put the panelists here today, all their contact details, should you want to contact them after the event today. So today we have Rob Zagarella, who's co-founder and CEO of NNCo, and also a LoRaWAN ambassador. We also have Matthew Barbuto, who's co-founder of the company Wynomia, and we have Wayne Love, who's a business transformation manager at PTC. So welcome, panelists. Glad to have you aboard today, and thank you for sharing your expertise with the SCLAA audience here today. Now, we are going to have a Q&A session at the end of all three panelist speeches today. So the reason we've done that is so that if there are any questions that any of the panelists would like to answer, then we can do that. So for instance, we may have a question where multiple panelists would like to chip in on that. So at the end, we'll have all those questions. As we go along through the presentations, please enter your questions in the Q&A box. You'll see that at the bottom of your screen. Enter those as we go through, and we'll put those to the panelists at should be around 11:30. So we have a lot to fit in today, so I think we should get started. And first off, we have Rob Zagarella, who's co-founder and CEO of NNCo, and we've got a lead-in video which I'll start now before Rob starts his presentation.
We have the power to improve supply chain safety, logistics, and asset tracking for efficient and effective resource management. Member Abiway has more than 100,000 tracking devices installed on assets around the world, from trucks to equipment to people, and anything in the logistics chain that's on the move. The team at Amazon Web Services enables logistic companies to use LoRaWAN to monitor their fleets and inventories.
And Member MachineQ, a Comcast company, has deployed outdoor asset tracking and inventory management, including vehicle location management for one of North America's largest automotive marketplace companies.
So with that, I would like to welcome Rob Zagarella. As I said, he's co-founder and CEO of NNCo and a LoRaWAN ambassador. Rob is a global business leader with proven ability to translate vision, strategy, technology, and innovation into existing and new commercial revenue streams across a range of industries, including energy, utilities, telecommunications, and defence. He's been an innovator and an inventor in IoT in the area of machine-to-machine sensing, communications, wide area networking, and enterprise software, and has successfully leveraged those entrepreneurial skills as a leader in startups both in Australia and the US, university-based commercialization, and large global corporates. So with that, a big virtual welcome, Rob, and I'm going to hand over to you.
Thanks very much, Stephen, and really excited to be here today. and representing Inanenco and as an ambassador of the LoRa Alliance, and talking about LoRaWAN and how it can apply to the supply chain logistics market. So thanks very much. Okay, so just a little bit about Inanenco. So we are the longest running LoRaWAN operator here in Australia. We've been around for about 6 years. We are actually a contributing member to the LoRa Alliance, so we're involved directly into the various committees, certification, standards, and marketing. So that's really quite a privilege for us. And we're really about enabling, businesses and government to really drive and adopt IoT on scale, leveraging any type of device or sensor, network, and upstream application. And that's, I think, again, a really exciting place to be. And as mentioned, we started in 2015 in Australia, and now we're also launching and expanding globally. As a company, Inanenco is really being built from the ground up to scale. We have an experienced board and executive team that has, quite deep and long-standing experience in both the telecommunications industry and the industry at large. And as a telco carrier, we really see ourselves as a hybrid telco carrier, where we're providing a carrier-grade service, but we're actually partnering deeply with industry to really understand requirements of IoT and really meet those requirements end to end. And of course, we see LoRaWAN as an open standards-based technology that is really a massive enabler for us to apply that philosophy into the markets, particularly here in Australia. And of course, today here we're talking about how LoRaWAN and the Internet of Things can apply to two key areas, which is asset tracking and logistics. So if we talk about the internet and we talk about the Internet of Things, it really is the next wave of the internet, particularly when we're talking about industrial IoT and how it relates to the enterprise. It's a massive market. It's currently at around that $120 billion per annum. So it is big, but it's also important. And why is it important? It's important because it really does provide the opportunity to connect the physical world with the digital world and really drive seamless communication between people, processes, and things. And that really enables IoT to be pervasive across many industries. So obviously here today, we're talking about cold food chain logistics and the supply chain, but it also has quite a deep relevance into, other massive industries such as energy, utilities, agriculture, healthcare, and also really important thing is also the environment. And again, enabled to really drive that interaction and connectivity between people and the environment that we live in. So it really is at a point where it is touching, and it will touch just about everyone on the planet. But there have been challenges up until now in terms of, the widespread pervasive use of just simply connecting a sensor or device to the internet. That concept has been around for a long time. I've certainly been involved in it since around 1993. But why hasn't it become pervasive yet? And it's really these four key challenges. One is range and penetration. There are personal area networks, there are cellular networks, there are Wi-Fi networks. But when you're connecting and need to connect to a sensor and device across many different industries, you need range and you need penetration, hence the wide area aspect of what we're talking about. And it's really important to have the capability to guarantee that connectivity to wherever that sensor may be, static or movable sensor. These sensors are typically battery operated. Again, they're connected out into the environment, which means that power consumption is really key. You need these sensors and devices to be operating for many years, not many weeks or many months. And when we're talking about scale, we really need to talk about cost, and being able to manage these services and capabilities with end-to-end security across those. Cost in many cases in history has been a prohibitive factor. And we think that that's really changing now. And of course, the business model is important. What's important about IoT is about data, and providing contextual information around that data and being able to apply it to the various commercial models to meet various aspects of the industry. So having that flex commercially and from a business model perspective is really important. So what does success, look like, and what does, success require? It really does, require capability and knowledge to really bring many aspects of technology from an end-to-end perspective, together. It requires an understanding around sensors. Sensors are key because they are really the bridge between the physical world and the digital world. And of course, being able to apply that through an optimized network with end-to-end security to bring that data back to where it counts. And where it counts is in applications, of being able to use existing applications and develop applications that can help users make decisions very easily with that information. And of course, there's privacy compliance challenges and information that's required. And then, of course, how do you get that data to where it is needed? So the integration of that data and being able to leverage, out of the box artificial intelligence and machine learning, and have that information integrated into, existing industry workflows is really important. And bringing that all together is really what it's about. And, there really is a lot of, and there has been a lot of hype around IoT that we're really starting to see, particularly in the area of LPWAN, which is low power wide area networks, which is the area of IoT that really we're focused on here. I mean, the numbers really are starting to get to that real sort of J curve is really happening. And we're seeing an estimation just in the next few years of almost 3 billion IoT devices. So we're starting to get to that inflection point of having more IoT devices than there are people in the world. And that's, again, cutting across, many different industries, as we talked about. But I think relevant here for this discussion is that, and I think is a really interesting stat, is around the growth of IoT in relation to transportation and supply chain as being the fastest growing vertical for LPWAN. So I think that's a really important aspect for us to really sort of, look at this and sit back and really pay attention to the industry that we're involved with here, so we can take advantage and leverage this this trend. And when we talk about, LoRaWAN, we're really talking about the ability to really drive massive adoption of IoT and the ability to scale. And we're really seeing that now around the world, and LoRaWAN becoming really the global de facto industry standard for LPWAN. And there's many reasons for that that we are going to cover off. And it really starts with some of the key, differentiators. The LoRaWAN tech is really flexible from the perspective of that it is able to be applied to both public and private type networks. So typically, historically, you've got sort of the cellular type networks, and then you've got, the proprietary networks that have been built, in areas where cellular hasn't really been able to meet that need. But here we can cover both of those types of deployment options. The ability to have a technology that's going to withstand the test of time, And that means being able to actually manage and remotely monitor and upgrade software within those devices, so we don't need to send out a truck roll, which in many cases can kill a business case. The geolocation aspect of LoRaWAN is really important. It's inherent actually in the protocol. And we're talking about two-way communications, two-way secure communications. So it can uplink information from a sensor, but it can also control and actuate a sensor. And obviously the long battery life. So we're talking about 10+ years of a sensor and device running off a battery before it needs to be touched by a human. And that's really important. And of course, that wide area coverage. And we're seeing that in many of the deployments actually that we've driven here in Australia in the agricultural area. And of course, the ease of integration of how that data gets integrated into the different workflows and upstream systems and applications. So what does this mean for, logistic and supply chains? And we're really, focused on 3 key areas where we see that applicability. And I think this will be mirrored also across the the other speakers today. Wayne, as he's talking with PTC around asset monitoring, and Matt from Eunomia, who's going to be talking about some of the specific areas of automation in the construction industry. But asset tracking, just generally tracking these assets across the supply chain, I think is a real opportunity there for scale, particularly around things like monitoring temperature and the shock of these assets through that supply chain, and actually monitoring the goods. So not just actually knowing, where that asset is, but actually monitoring those goods within that asset and providing that real-time visibility is really important for managers of those particular areas, and providing that feedback to drive process improvement of those assets as they're moving through the supply chain. Inventory management also we see as a real key opportunity here, to be able to automate the manual process of the management of inventory, and just things like stock counts of the industry of assets, particularly in some of those areas where vendors are selling their assets on consignment. So a couple of, just sort of diving into a couple of the use cases that we've seen here in Australia, and cold food chain asset tracking is one of those. And we've actually just come out of quite a major trial with a large retail food provider across Australia that really needed to monitor, temperature of, fruit and veg and other food produce across that supply chain, from the food supplier location, which could be an ag manufacturing plant or just a food supplier, through the distribution warehouse, and then all the way through to that retail store. And in this case, we've actually provided the capability of getting that data through these optimized sensors through the LoRaWAN network across that supply chain. And we've done that by really focusing on the industry use case and actually strategically extending the network to support that flow of data. And there's a solution that we call NTrack, which has sort of been the sort of key enabler and the glue of actually bringing that sensor data with information that's logged through to that backend system to really drive actionable insights. The other key use cases around static monitoring. And one of the really exciting areas here for improvement is meeting regulatory and quite stringent regulatory reporting requirements for food and the temperature of food across any retail supplier of food, here in Australia. And this, presents the challenge around being able to actually drive connectivity into, in many cases, refrigeration and deep freezer units. In some cases, 2-3 levels down into the basement of a retail food chain, and guaranteeing that data to get through to the regulator. And again, being able to strategically locate the network fabric to support that use case has been really important and extremely successful. So if we look at what this means, we at NNNCO talk about the 4 pillars of IoT, because there's an opportunity to really sort of break down the various areas of IoT and really simplify that across just about any use case. And as we talk through that, if we move from the left to the right, it's really about, firstly, really understanding what is the right optimal sensor that's required, again, to sort of provide that bridge between the physical world and the digital world. And there's many different types of those available in the ecosystem, but applying the right one for a particular use case is really key. And then, of course, it's strategically molding the network fabric, the existing network fabric that we have, and the extensions of that network fabric for that use case, and then bringing that data back into the enterprise and into the supply chain. And there's many different types of devices that can be suited, and we leverage those. We talked about Abiway in the original video, but there's a global supply chain of these devices that can be applied. One of those in particular that is really exciting and really talks to the disruption of this technology is the tag. We actually have now here in Australia the ability to actually have a tag that can just be literally peeled and stuck onto any asset. It weighs about 6 grams, it's wafer thin, and it has a battery life of several years. Very exciting opportunities here. And just to give you an idea of, just to visualize what some of the, when I talk about network fabric, these are the types of network termination units that we use. These are portable units that can be used in use cases such as construction. The indoor type of gateways that can be used in the refrigerated loading dock areas for cold food chain. And these, what these gateways look like in an outdoor setting on a large tower or rooftop. Aggregating that data and the platform around that data is really key. And this comes with the network. And we have a system that can really scalable, provide normalized data, contextualize that data to really help drive that interface into the applications where these decisions are being made. And of course, visualizing that information through existing partner visualizations or putting together visualizations for particular use cases is an example here of what's been rolled out in the feed and that in the field, and that involves asset information as well as location information. So thanks very much, Stephen. I hope that was useful. Contact information here, and really keen and looking forward to the rest of the speakers' presentations. And we're obviously here to really help this industry and work together to really make some really exciting and wonderful things happen. So thanks very much for your time. I think you might be on mute, Stephen.
Thank you very much, Rob, for indicating that I'm on mute and for your presentation. I think that was very insightful, and I can see there's some real benefits there over, I guess, traditional connectivity via Wi-Fi and 4G, 5G. There's a few questions there for you, so we'll cover those at the end of the presentations. We do have a poll now, so that's coming up shortly. All right, so you should see that poll now. I'll give you 20 seconds or so, and I will then share the results. Everyone can vote there. And just to pick up your point, Rob, while we're waiting, about in a cold store using narrowband technology, LoRaWAN, to get that penetration through a cold storage. I know that's a real challenge for Wi-Fi in those with aluminium walls typically to get the signal where you need it. All right, so let's end that poll. And we have a tie. So asset tracking and automated inventory management are a tie at 45% and monitoring goods 9%. Very interesting.
Fantastic.
Next up, it's my pleasure to introduce Matthew Barbuto. So Matt is a co-founder of Wynomia, an IoT technology business which is commercializing Bleat, an innovative Bluetooth low energy radio frequency IP created by CSIRO's Data 61. Wynomia is developing Bleat into the market's leading IoT platform for the construction industry, creating real-time location monitoring of the key resources which impact project success. So with that, I look forward to hearing more about that IoT application in supply chain for the construction industry. Over to you, Matthew Barbuto.
Thanks, Stephen, and thanks very much for having us on the panel today. And a great introduction from Rob. A lot of the technologies that he mentioned and LoRaWAN in particular are part of our own solution. And so, yeah, there's a lot of things that he spoke about which will be in a slightly different perspective in what I'm going to talk about today. So this was the general topic that I wanted to cover, and given that the audience is more of a general supply chain background for the most part, for myself, just to give you some context, I worked in supply chain for just over 10 years before I co-founded Wynomia about 3 years ago. And I would say I know quite a bit about manufacturing and retail supply chains. I didn't know a great deal about construction supply chains and have been fascinated by how similar, but also how very different they are to what I was familiar with. And a part of that complexity, if you go beneath the surface, is driven by the project nature of construction. And again, for those who are not so familiar with the industry, construction represents, depending upon the geography, but globally, it's near enough to 10% of GDP and about 10% of employment in most countries, higher in different jurisdictions. But that gives you an order of magnitude of the size and scale of construction. And anyone who lives in a populous area like a CBD or spends time there, you'll definitely see the velocity of construction happening in Australia. And so because those projects are unique and every building has its unique characteristics, the supply chain coincidentally becomes quite unique as well. There's a level of fragmentation in terms of most construction is subcontracted. So in the way that a lot of transportation is subcontracted, you have different parties who, unlike in transportation where there may be more, they're more divergent, they're all coming together in the one space. So if you thought about that, you know, having all of the different subcontractors coming together in one physical space and building the space as they're actually interacting within it. And so what that creates is a significant amount of logistical constraints on site in terms of how people move around the site, how assets move around the site, and how materials move around the site. And so that's part of the context that I'll talk about today. And so how we've been applying IoT into the construction industry is really focused on helping to deliver projects in a more timely fashion. The vast majority of large commercial and infrastructure projects will be delivered late, unfortunately, in this country and most others, and most of them will be delivered over budget. And in a very low margin industry, the average profit margin for a large commercial construction project is sort of 2, 3, 4%, depending upon where it's being constructed. But as you can tell, that's a lot of risk relative to the return that's being generated, and a lot of time and capital invested into those projects. And so you've got different stakeholders. You've got upstream the developer who's commissioned the building. You've generally got a builder or general contractor, as it's called in the US, who's responsible for orchestrating all of the building, and then a whole bunch of subcontractors across all the different trades. And then there's an extended supply chain of component suppliers. Some of those things commoditized, like taps and fittings and things that you would be familiar with. Some of them more custom and bespoke, and where a lot of our focus has been on those custom bespoke elements that have a design component and that have to be positioned in a certain location within the building. So if you thought about that in you're using a more traditional supply chain example, imagine if when you were transporting an iPhone, it was a bespoke iPhone and it had to be received by a certain particular person. So Rob has ordered an iPhone and it's not just any old iPhone, it's this one and he has to get that one. That's basically how construction happens, in that certain components of the building to form the building have to go into a particular location because it's been designed that way by the architect. And so there's a lot of things that make the challenge and the opportunity of construction quite significant for IoT. Our original thesis when we started out doing this 3 years ago was inspired by something that kept coming up when I was starting to talk to people in the construction industry about IoT and about how it could potentially be a disruptor and a real game changer for the industry. And the expression that was used quite often was that people describe construction as organized chaos, and in a very, I guess, respectful way, in that, you know, that the engineering that goes into large scale construction is just phenomenal and really, really impressive. But because of a lot of the practical constraints that I just mentioned, the way that the activities happen, there's not a lot of digital penetration on job sites. There is, you know, a lot of people don't use tablets, don't use phones, don't use laptops in the way that we would. Part of that is a generational thing, but also it's about the environment. And like what Rob was talking about, certain technologies like Wi-Fi that we take for granted in environments like office buildings, when a building is being constructed, that doesn't exist, and the cost to implement the infrastructure that would create connectivity in a construction site is not appropriate for the transient nature of construction, where a project might last for 1 to 5 years depending upon what's being constructed. So that was what we set out to do with Wynomia. And as Stephen alluded to, we're doing that using a technology which was developed within CSIRO. Up until this, I had no previous background working with publicly funded research organisations like CSIRO, but for those who aren't familiar, it's our national research and science agency here in Australia, inventors of Wi-Fi, which is one of our, as a country, one of our greatest inventions. They also have invented many other things, some of the early components of Google Maps. And the polymer banknotes that we use in Australia and many other countries have since adopted is also an invention of CSIRO. And so they developed this technology, BLEAT, which stands for Bluetooth Low Energy Aware Tracking, and it was designed for location awareness in challenging industrial environments. So think of construction, mining, industrial facilities like warehouses, where again the conditions aren't particularly conducive to good radio frequency signals. And so this is the problem in construction. Job sites are organised chaos, and depending upon the source of the information, most research, this one from FMI in a report that was issued in 2018, indicates that roughly a third of the time spent on construction sites is being wasted. And a lot of that waste is caused by the inability to access information and resources. And I guess information comes in many different forms. That might be the plans that are required for building. And again, in some cases, that might be printed plans. People might have to leave the construction site to go back and get a hard copy version of the plans. A lot of the information is changing. Design changes are happening all the time when the building's being constructed. So having the most recent information can be problematic. But our piece of that puzzle is really focused on the physical resources and where they are, and being able to locate them, because the transient nature of construction projects means that they don't generally run traditional inventory management systems like you would find in most supply chain environments. Things don't get reported necessarily through an ERP or a warehouse management system. They tend to flow through multiple locations, from manufacturing to potentially cross-dock facilities, then to the construction site. Very little of that actually involves any form of tracking, scanning, receipting into inventory. Things just tend to arrive at a construction site. They get put somewhere. They get moved around several times because the space is constrained. There's no warehouse necessarily on the job site, and especially in CBD locations, there's very little space to store materials. So what we set out to do was leverage this technology, which was developed by CSIRO, and apply it for this particular purpose, to provide real-time visibility, to improve job site operations, and to help with the status and sequencing. So again, anyone who's done any kind of building work, even at home, you would have realized that the sequencing of trades, you know, getting the plumber and the carpenter and the electrician all to sort of come in the right sequence is often problematic and a tough thing to coordinate. Imagine when you've got people, equipment, materials for all of those trades. On a commercial construction project, there might be 20 or more different trades. and they're cycling through the building, especially in a high-rise context, they're having to keep sequencing and resequencing all the time. So there's a lot of areas where information is not available in real time, and especially information that relates to the supply chain, or especially if we've got offshore production of materials, which a lot of the Australian construction projects have. So this is really the space that we sit in about what we call automated execution tools. So like I said, time is everything in construction. The time is money, time is quality, and time is safety. So if you can do things in a more timely fashion, you can build more effectively. There's really good tools in construction for planning, because a lot of the work involved in something like that, you could imagine, relies on really sophisticated planning tools. There's also a lot of good review tools to look at what happened and how things have evolved and how they can potentially be done better next time. But there aren't a lot of tools that are really available for what we call real-time visibility into construction for both supply chain and site-based activities, and that's really what we're targeting. So this is the technology. Just a little bit of background. Like I said, I had no previous dealings with CSIRO. Amazingly, the quality of the researchers we have in this country is just amazing. Back in 2016, they tend to have a fairly wide license to explore new technologies, and Bluetooth tracking was not necessarily new, but what they had looked at was finding ways to overcome the inherent limitations of Bluetooth, which is range is the most common one, and blend it with LoRaWAN. So the technology that you just heard Rob talk about, and all of those benefits you could hear about in terms of penetration through glass and steel and concrete and the things that are existing in a construction site, as an alternative to technologies that otherwise wouldn't be implemented in those types of locations. And so, as you can see in the picture, this is the device that we developed with CSIRO, and it operates on effectively can speak two languages. So it's speaking in Bluetooth locally, and Bluetooth is a powerful and ubiquitous technology, as you would all be familiar with, because it runs on cell phones, it runs on very low cost tags. So devices like this, they can last for a very long time and cost next to nothing. They're made in large quantities and are readily available. A lot of things on construction sites, like tools, for example, most major tool companies sell the tools with embedded Bluetooth tags. And so the interoperability of Bluetooth makes it a really good medium or a good communication protocol for localization of resources within a construction site, both animate and inanimate objects. But then you need to get that data somehow back to the cloud in a timely enough fashion that it can be visualized by people who aren't right there in the environment. And that's where LoRaWAN comes in. And so that device effectively is used as a location beacon. So smaller devices like this one and the other one you can see in the screen there that are attached to things will use this as a reference point, just like how cell phones would use the cell phone towers or satellites to position themselves using GPS. And so effectively what it creates is like a Google Maps type experience, but in a construction site, which is something that we probably all take for granted in how powerful those tools are to be able to find the nearest petrol station, the nearest cafe, the nearest restaurant. So that's really the core of the technology. But as we evolved it more and more, we came to realize that a lot of the risk in a construction site is happening on the site, but a lot of it is also happening upstream. And because traditionally construction hasn't managed the supply chain particularly actively, it's been more things will turn up when they turn up, and then we'll just kind of deal with it as we need to. I think there's been a real shift in thinking to take a more proactive approach to know where are things at through production, through shipping, through maybe what's being held off site, how can it be called up in an efficient way to the site to minimize how much material comes on earlier than what it needs to. And so this technology has really evolved as being very well suited to these particular use cases. There's a patented aspect of the technology, which is effectively about embedding rules onto the tag. So I think it's important that if you're thinking about IoT applications today and into the future, these tags, to what Rob said, they're getting cheaper and cheaper all the time. The form factors are getting smaller. The ability to operate even without batteries in a kind of a sticker type of form, like what Rob described, it opens up so much opportunity of what we'll be able to do with these tags. And if you think about how slowly we've evolved from barcode scanning and QR code scanning, and RFID probably has always had a range constraint which made it a bit limited. As these types of technologies that have more range and more power, more power conservative, and in our case, we're able to embed rules on these tags. So depending upon what they're attached to, we can expect certain behaviors. So when those behaviors don't happen or do happen, when something moves into a particular geofence area or a particular zone, we can trigger alerts to notify the relevant people that something good has happened, something bad has happened, or more importantly, some kind of exception exists that we need to deal with. So that's kind of the core of our technology. Like I said, we're leveraging both Bluetooth and LoRa. So CSIRO, like I said, developed this technology, kind of, one of many they've done in the radio frequency sphere, and then we're commercializing it in this case for construction initially, but through that process, I guess, looking to adjacent industries that have similar environmental conditions and similar kinds of requirements. And so this, I've just included a couple of supply chain examples to kind of give you a flavor of what that looks like. This is, and one of the other things I thought was interesting is, with buildings, one of the great assets we have is that there's a logical visualization, as you can see on the left of screen there, that the building becomes a really useful tool. I think when you're thinking about IoT applications for supply chain, it's also worth thinking about, when you could, if you could access a lot more passive data about where things are in the network, how would you then think about visualizing that? Because by definition, distributed supply chains can be quite complex to visualize. So the way that we've done that with building as our core use case and construction, as you can see there, this is what's called the building information model. So the 3D representation of the building. And what we do is associate locations with statuses. And so based on the location coordinates we get from the tracking devices, we know that that represents either a particular area of a production facility, in this case, a glazing facility where they make the windows for this particular building. As you can see, it's quite a customized design. Every window is uniquely numbered and identified. There's particular types of glass, shades of glass, frames, and different things that exist. So every piece has a particular location. There's somewhere in the order of over 2,000 of these glazing units that have to form the building, and effectively what allows them to envelope the building so it's now protected from the elements. And so that is an example there where you can see statuses represented by color. So all of that being automated. Basically a tag like this is attached at the very start of the process, and then through its location, we're able to infer its status, and its status then updates. And that visualization tool, this model, updates in real time. So anytime one of these moves into a different location, or a location which has a different status. And what we've been able to do to manage that is, over the course of the project, understand how much material really needed to be in the supply chain at any point in time, not something that's historically been actively managed in construction. And in this case, we're able to pull a lot of material out. The average value of these units, they're worth thousands of dollars. So from an inventory perspective, it's very expensive inventory. Like I said before, the contractual nature of construction means that in most cases, the developer won't pay until the materials are on site and installed. So everybody downstream from the developer has a really vested interest in minimizing the amount of inventory in terms of cash tied up in the supply chain. But there's also the offset, which is that there's a huge risk, because if you deliver the project late, and this particular type of material could be a massive implication of a late delivery of the project, then there's penalties, liquidated damages, which might be tens of thousands, maybe hundreds of thousands of dollars, depending upon how late the project is. So it's very much sort of like a traditional supply chain. If you're balancing, what would an out of stock represent? In this case, an out of stock of these materials could slow the whole building, or could even stop the building, because certain internal works couldn't happen until the building has been completed on the outside at least. And so this is a really good example of how we were able to manage that balance of risk and waste, I guess, or excess material in the supply chain. That was in Australia. This is a project in the US that we've just deployed recently, one of our first big projects over there, which is great. The workflow or process basically is, this is Google's head office in Austin, in Texas. It's a 35-story building with 10 levels of car park below. So a very large building. There's a lot of complexity in the flow of materials. In this case, frames and doors are a big component part of that. And each of them, again, has a particular location where it has to be installed. So you can see there's some of the imagery of how we deploy the network using a smartphone. So again, Bluetooth is helpful because it means you don't need any technicians to deploy these networks. And I think that's something to keep in mind, that it's getting easier and easier to deploy them. It's getting much more cost effective to deploy them. And the utility that can provide in this case is really putting into the pocket of people out in the construction site a level of information about the real-time location of these materials. At any time they can access that. They can access information about not only where they're located, but they can also call up on the right of screen there. You can see some of the elements or the important pieces of information to ensure the right thing is installed into the right place, which is really important. And that's also represented in 3D in the model in the same way as what I showed before, seeing statuses with different colors and also being able to look at a lot of the granular detail behind those individual components. I think the stat is that something like 15% of waste in construction is through rework, the same work being done more than once. And that would be a very good example where the wrong door gets installed in the wrong frame. Maybe it swings the other way, or it's a different type of door. Some of them look the same, but they're not. And when time is of the essence and people are working under pressure, it's easy to make those kind of mistakes if you haven't got the right information. And then just to kind of give you the last final example, this is maybe where we're heading into the future, beyond the supply chain component of it. This is a project that we expect to start soon in the UK. It's the building of a prison. You can see there in the bottom left of screen, it's a massive site. Each of those X's represents a building. That's effectively one prison block. There's 14 of them on this particular site. And for that project, we'll be tracking nearly 15,000 components, so material components, primarily the structural elements that will form all of those buildings, about 1,000 operatives or workers on site, broken up into different work zones to understand the productivity and efficiency of how they move around the site, and also help them from, if you think about sort of a lean planning perspective, helping to position the equipment, tools and materials in the most accessible areas where they're needed to minimize waste, because people could spend a lot of time walking around that job site in an unproductive way. So we're trying to maximize what we call in construction tool time or productive time, similar to what you would find to kind of pick path planning in warehousing. And also about 300 pieces of equipment. So things like you could see there, an elevated working platform or scissor lift, those type of things. Again, being able to locate them quickly and being able to access them and use them to do works to allow other trades to continue is really important. So that's an upcoming project in the UK. We are involved in a project here in Australia, which I think is interesting, both in terms of its focus on supply chain, but also IoT. Building 4.0 CRC. CRC stands for Cooperative Research Centre Project. And that is something that the federal government funded about a year ago. The combined funding is about $130 million to allow us and 30 partners, including big players like Lend-Lease and BlueScope and companies like that, to undertake these research projects. Some of them are quite small scale, some of them are longer in term. These ones that I'm showcasing here were some of the first ones off the bat. So you can kind of see that within construction, there's a lot of interest in supply chain. So automated tracking of construction materials, this interest in provenance. So where did the materials come from? Were they ethically sourced? Were they sourced from the right places? A lot about it, data interoperability through systems, and then about collection of data in a more passive rather than a human-centered form. So each of those is a $500,000 R&D project. It's a really good program for us to be part of, and really good for our IoT solution to be able to be tested in different types of environments. I've got a bunch of other use cases, but I'm thinking that's probably about time, Stephen.
Yes, thank you, Matt. Appreciate your presentation there, and it's great to see some use cases there. I'd imagine the ROI, the return on investment, would be incredible for a building site to know where all their stuff is, and particularly with COVID-related delays at the moment. Supply chains are a mess. I could imagine the benefit there. So thank you for sharing, and there'll be some questions at the end. Let's go to another poll. Oh, wrong one. Polling 2. Okay, here we go. Do you think the reality of IoT for supply chain applications will ultimately meet the hype? There you go. No, 3 years, 5 years, or 10 years. Please put in your votes. All the votes coming in. Interesting. All right, we'll end polling there. So it appears most people think it's 5 years to meet the hype. So there you go, interesting results there. Thank you everyone for participating in that poll. And now it's my great pleasure to introduce Wayne Love, who's a Business Transformation Manager at PTC. He's an IT leader and Senior Business Manager, now working with PTC to help his customers identify and derive tangible value from IoT and AR technology. So with that, I'll hand over to Mr. Wayne Love. Over to you, Wayne.
Stephen, it's great to be here today, and I appreciate everyone spending the time with us. Look, I just want to call out something. Today, what's great to see, sorry, can I just confirm it? Can everyone see my screen?
No.
Try that.
Yep, we've got it now.
Fantastic. All right. Yeah. So what I was saying is, what's great to hear from both Rob and Matthew is that there's a lot of common topics that we are all addressing. We're using different terms, we're using different words and phrases, but we're talking to the same drivers behind the adoption of IoT, the same use cases within supply chain and within industry in general. In all honesty, for example, within PTC, we're heavily exposed to the defence industries. Do a lot of our work there. So the FA&D companies, the concept of track and trace, this is a problem that they're desperately trying to solve. Yeah, Matt, you and I need to have a talk about this afterwards. But this again is common across any project-based industry. The desire for asset tracking, which came up in the poll that Stephen ran earlier on. These are drivers that everyone's feeling the pain around. But there are solutions available now or on the near horizon. That will help us address these problems. With that, I'll just jump into my deck. A bit of agenda. I'm going to do an introduction around who is PTC. Then I'm going to want to unpack about what is IoT, and then the key enablers around IoT successes. A quick overview of our ThingWorx platform, which derives our solution space for IoT. And then some lessons that I've learned personally from the past years of working in IoT related projects across multiple different industry verticals. So who is PTC? PTC, we started around about 30-40 years ago as a CAD company. The old Pro Engineer, for those people who are working in engineering will probably know us from that. We've evolved from that and now are a global company, 1.5 billion revenue, 6,500 employees globally, mainly located out of Americas and Europe, but a lot of growth here in Australia in the APAC region. A bit of trivia for you: when COVID hit, we pushed our AR-based technologies out into the market as a free-to-use to help companies get over the COVID cycle. And Australia per capita was 4 times more likely to adopt AR than any other country in the world. So that is an amazing statistic to show how willing Australian companies are to adopt new technologies, to try out, to explore what's available in the idea of improving themselves. So I've mentioned ThingWorx, I've mentioned our AR. This is PTC's full technology suite. You can see we go from CAD into product lifecycle management, into industrial IoT, and then onto AR. So what our view of our value to the economy or to companies is that we have this capability to deliver digital transformation projects from product conception through to it's sort of scrapping throughout its entire life cycle, and doing that we use IoT and AR, and I'll come on to how AR fits into this story a little bit later because it's not obvious. But in IoT for us is the glue that brings all this information together, that allows that information to be collated, to be contextualized, and to be normalized to be consumed throughout other business processes. A bit of a brag slide here. These are the analyst magic quadrant charts. What I want to call out on this is that every analyst has a different view of the industrial IoT landscape, but what is consistent amongst all of these is PTC, regardless of who is around us, PTC is always in that top right magic quadrant in our ability to deliver and our technology capabilities. So we're always up there, regardless of who you talk to, which is a great endorsement, if you ask me. So what is IoT? So I'll rephrase it. What is industrial IoT? So when Stephen first asked me to do this presentation, I threw back to him to say, okay, what are the pain points that the members of your organization, where are they hurting? And he came back to me with these 4 pain points to talk to. So just unpacking these a little bit, around the freight tracking and quality control, we have the ability with vehicle telemetry that alerts a driver or a freight company if the temperature of a transport deviates from predefined parameters. Rob spoke about this in terms of the pervasiveness of LoRa and the ability to read or get that data from inside, essentially Faraday cages, which is what is the back of a semi becomes when you close all the doors up. That ability to get that information out is something that's become prevalent. Fleet management and tracking of vehicles. Vehicle telemetry. We can track vehicle usage and the KPIs around that. Where a vehicle is, where it should be. Is there a deviation? Is there a gap? We're talking here about geo boundaries and geo fencing. Deviation from planned routes. All of this is now possible. And what this does is it allows us to actually build a view of, okay, well, this truck, it's due for a service. So we need to schedule a service in. We need to identify immediately that a truck has gone off the road, for example, without having to wait for the driver to call in to say, hey, by the way, it's now failing to proceed. And on the warehousing, we have the ability for ERP, M&S, track and trace systems, such as what Matt was talking about, to real-time track the availability of products in a warehouse to allow for automated production orders to be set and purchase order to be generated. Batch serial number tracking, quality, that is very possible. But I want to sort of pause here. And because I can see virtually everyone around this virtual forum, so shaking his head and saying, well, what's new? This is all stuff that we've been doing for years. What I will say is that communication networks are getting cheaper. Communication networks are getting more pervasive. Sensors and devices are getting smarter and smaller, allowing them to be deployed in areas where we previously couldn't deploy them in the past. And then integrations into vehicles and into equipment are getting tighter for off-the-shelf devices. No longer are you looking at bespoke implementations of a monitoring system for a semi-trailer. You can plug straight into the OBD2 port nowadays and pull key engine metrics from the vehicle that you want to monitor, including using that same port to power things like GPS trackers and communication networks. So what is different? What is driving the need for industrial IoT? And I'll put it out there that what it is driving all of this is customer expectations. Our customers, and here I'm not talking about the customers that buy the product. I'm talking about the customers that consume the services that we all have as enterprise businesses. So these could be our suppliers. These could be the companies that we distribute to. These could be internal people that are responsible for doing jobs within the day-to-day operation of our businesses. So these customers have been exposed to IoT. IoT is different to industrial IoT. Yeah. IoT is your smartphone, your Siri, your Google Assistants, your Alexas. This whole concept of bringing data together across multiple data sources and visualizing that. So if we go back to the same points that Stephen gave me at the start and rephrase it in the perspective of what the customers are actually expecting nowadays. So for the freight tracking and quality control with the cold chain, the customer doesn't want to know what has happened to a particular vehicle. They want to see across the lifetime of a product, has that been stored and manufactured in the environment it's specified. So this is not just about a single company anymore. It's not about a single vehicle anymore. This is about from a company that's producing it, going to a warehouse, onto a freight, maybe onto an airline, into another warehouse, and et cetera and so forth. So we've got multiple companies, multiple storage facilities, but the customer doesn't care. They want that big green tick at the end of the day to say that this product is safe to consume. And for this, we need to start bringing together all of these disconnected systems into a holistic whole. And people are probably thinking blockchain at this point in time, and that is one way of addressing this particular use case. So the other side of it is that as a supplier, it's a double-edged sword. This, as a supplier, I want to prove to my customer that the delivery that I'm about to make, that simulator I'm just backing up to their loading dock, that they can't reject that on some spurious sort of excuse because they don't want the goods. These goods are being delivered as per my contract. They've been maintained as per the quality, and they must be accepted as per the contracted obligations. So it works both ways. If we look at the fleet management, the tracking of vehicles, what we see here is more of an internal demand coming out. So, as a maintenance manager, I don't want to know what's happened. I don't want to know how many kilometers my vehicle has done. I want to know how many it's going to do in the next month. So if it's getting close to a maintenance, to a service point, well, then I can start scheduling it in. Okay, I now know that a vehicle needs a schedule. What is the most optimal time I can schedule this vehicle? When can I, given all the orders, all the deliveries that we have to make, all the freight that we need to move, when is the best time to take this particular piece of equipment offline that's going to have the minimum impact on my supply chain? Sorry, so I just know I've got a 5-minute warning, so I'll push through very quickly. And again, with warehouse, the warehouse manager, you need to be able to react to external events that allow you to coast through, things like power outages by super chilling your warehouse. But the point is that the key enablers around IoT is taking this view of an enterprise, and the enterprise, industrial IoT is not just about sensors. It's about collecting data from the enterprise as a whole. And here's what I'm talking about, is your enterprise systems, your ERP, your MBS, your maintenance, your business processes, and modeling those business processes so that when a data point gets flagged, you know that the truck is out of temperature and what is the impact of that. So industrial IoT, it needs to be able to interact with these business systems. It needs to be able to influence them, because there's no point introducing yet another silo into our already complicated work environments. You need to be able to automatically generate purchase orders. You'll be able to automatically generate maintenance orders as required. But the problem with this automation, it can't become a straitjacket for your business. This can't be an IT or a consultant-led engagement. Your IoT platform needs to be reactive. It needs to be able to be changed by a business as your business has changed. The companies that were least affected by COVID were those who are the ones who are able to react to change most quickly. But more importantly, IoT not only provides solutions to these problems, but it offers new business opportunities. So service now can become profit center. So for example, airlines sell engines by the hour now. They don't sell an engine as a capital item. The same sort of thought process can be applied to quality. Quality certifications becomes a value add to your product, because you're certifying that quality for the supplier to automatically consume. There's no additional inspection to be required. So industrial IoT, it's dynamic, it's flexible, it encourages a citizen development model. It's holistic, it takes data from across the entire enterprise and outside of your enterprise. It's not another silo, and it takes the data that we're bringing here together to present it in a single pane of glass. There's no point having staff going into multiple systems to try to build up that big picture. You need to present it to them on a plate. So our ThingWorx platform is an industrial, it's an IoT platform specifically targeted towards industry or heavy industry. We do this, we use this to bring predefined building blocks to a company to allow them to bring them together in a quick and efficient way to give that quick time to value in a bespoke manner that addresses their specific problems. So if we look at ThingWorx strategy and IoT strategy from the IoT vendors in general, back in 2015, almost it seems like a lifetime ago, we were building to solve and then configuring. Nowadays, IoT has become an application that you can just consume. What we do now is that you take the application, you configure to solve, and then you build out the bespoke elements using the building blocks that we supply to allow you to achieve that unique value. So I'll just skip over these slides in the interest of time. One thing I want to call out here very importantly, IoT is not cloud. IoT can be in cloud, but it can just as easily be on premise or be a hybrid approach. It depends on the business that you're working in as to what is appropriate. So just to start wrapping this up, some insights from the field. There are some really easy low-hanging fruit that people can address. Paper, surprisingly or not, is a huge barrier. Paper is probably the number one ROI focus that we have around removing of paper, about automating of business processes, about breaking down the data silos. All of these elements can combine quite easily to give a very good ROI on the cost of implementing your IoT platform. Do not reinvent the wheel. There's no point going out there and building your own protocol translation kits to bring all these sensors together. There are companies such as PTC. We do this day in, day out. Do not try to worry about database schemas, service messaging in bus, and all the other IT elements that the people can bring together to build a do-it-yourself platform. By adopting a platform that's pre-built, you can get a 4-time reduction in time to value around the business propositions that you're focusing on. I mentioned AR earlier on. AR, people think as being this new thing that's coming to market. It's not. We've been doing AR now for years. Really importantly, AR is not about headsets. A majority of our AR deployments actually use smart devices because they are pervasive and they are there, and headsets are down the track, sort of Horizon 2 development for our AR deployments. Coming back to the application comment, AR is akin to Word in terms of the complexity about bringing together a AR set of work instructions. It's not a development exercise now. It's flexible, it's quick to do, anyone can do it. You just need the media and the metadata to bring those work instructions together. So if you can do a Word-based work instruction, you can do an AR-based work instruction now. And the advantage of this is that we have studies that actually show that the cognitive load required to complete a task using AR is significantly lower than if you do it using normal paper-based instructions. And the advantage of this is that you get better quality, you get more efficient work processes, and you get better, so less errors being made, which leads to this better quality. Last slide, bringing it all together. IoT is a journey. It's something that you will learn along the way. Don't try to boil the ocean. Don't try to do everything at once. Set strategic goals by all means, but achieve these goals through these low-risk projects that are short, sharp, and easy to find. IoT is about business. It's not a technology. It's not a technology-led driven project. Your IT department doesn't lead these projects. Your strategic goals that I've mentioned must be business goals. These are business-driven goals that you're trying to achieve. They're not around technology. Can't emphasize that enough. Everyone's IT journey is going to be different. You can't just buy a solution out of the box. You can't just buy that Industry 4 or industrial IoT solution, say, yep, done that, move on. You're going to go on a journey. Every journey is going to be different. I don't care if you're doing the same thing as your neighbor. your journey is going to be different to your neighbours, because your business problems are different to your neighbours. And just to quote a good friend of mine, Dr. C. Downey for RMIT, the biggest mistake you can make is to do nothing, just do something. This is because IoT and AR are here and now, and they are commercially available and viable applications. They're no longer these technologies that need to be explored. And with that, Stephen, I hope I haven't gone too far over time.
Thank you, Wayne. Appreciate that. And something I got there is the importance of the business insight aspect of IoT. So data is great, but the focus has to be on the insights into your business that you get from that data. So thank you very much for your sharing your expertise. I appreciate that. We are running a little bit behind, but I think we've got time for 2 or 3 questions. Rob, a question for you. Could you tell us a little bit more about the community sharing aspect of LoRaWAN? And so like a company, an organization may have their own LoRaWAN set up, but tell us a little bit about that sharing aspect of that technology.
Sure. Yeah. Look, once a LoRaWAN network is set up, the way LoRaWAN works is the devices communicate through gateways into a network core, and there are different types of network cores available. So, for example, we have a network core that's installed locally here in Australia, because it has to, because for many of these use cases, the data has to be sort of kept locally. But that's then available for anyone to leverage on a secure basis. So, for example, when we deploy these networks for cities, like for example for Gold Coast or Newcastle and so on, that data from these sensors can be then made available and can be accessed by the community. But end-to-end security just needs to be managed and put into place, because when you have these networks monitoring critical assets, absolutely that data and information, and you want the community engaged into that network, but it just has to be done in a way that's not going to sort of compromise processes for the industry solutions that are running over it. But it's absolutely can all run in parallel.
Fantastic. Thank you, Rob. I've got a question here from Rakesh, a very broad question to all panel members. To what extent do you believe that IoT is enabled in supply chain world, and any particular points for showing resistance from the industry? So if I could maybe get Wayne to speak on that one.
Look, a couple of points here, Stephen. First of all, where IoT has been imposed on people in the supply chain, they see it as a cost-driven exercise. They don't see the benefits. This comes back to the point that you highlighted from my presentation about identifying the business value and the ability to reuse infrastructure to derive both value and address requirements from further up the supply chain. Aside from that, look, it's early days within Industry 4 and IoT. What we are seeing is that the landscape is evolving. You saw how PTC has changed our approach to market in the past 6 years. And I wouldn't say that we're not unique in this. Everyone's going through this exploration phase about, what does IoT actually mean for me? And how's it going to help my business be more profitable and more sort of, desirable to deal with than my competitors.
Great. Thank you, Wayne. Matt, I've got a couple for you. I'm going to put 2 questions into one for you. First one is going to be a fairly easy one for you, I think. This is from Rakesh. What happens to the devices once the construction is completed? That's number one. And if you could also talk on the ability of the construction industry, how receptive are they for disruption? So are they open to technology like IoT and are just waiting to get those efficiencies, or is there some pushback there? What can you tell us on those two?
Sure, 2 good questions. So as much as possible, we try to recycle the devices. Generally speaking, depending upon what the use case is, they will be moved throughout the building as the building evolves, and then those devices that are used for tracking of assets and materials and equipment, they will often have multiple lives during the course of the project. So an asset might come on site, it might get tagged, it might be on site for several weeks or months, and then as it's going off site, the tag will be deactivated and then relinked to a new tag. So we try to reuse them as much as possible during the projects, but also at the end of each project, we will refurbish them, perhaps change batteries where they're required, and then use them again for future projects. And that's one of the things that probably we didn't mention in the discussion, but most of these devices, they can transmit packets which relate to lots of different things. So there were some good examples, especially in Rob's presentation. The packets of data might be about, temperature or conditions or ambient sort of things. It can be about location, but it can also be things like battery life. So having the ability to for a device that's low cost and inexpensive, be able to tell you that it might be running low on battery and give you an early warning to that is very powerful. To the second question, so when I was coming out of supply chain and refocusing into construction and construction technology, I did a lot of reading, as you would expect. There's a famous McKinsey report from around 2017, and it basically lines up all major industries, and it lists them based on a scale, and it represents how well they have gone at adopting new digital technologies. And the construction industry, it's famously quoted that it ranked below all other industries with the exception of hunting and fishing. Not one of the industries you'd probably expect to be particularly proficient in such things, but it was like a real outlier that construction, like I said, is more than a $10 trillion industry. It's everywhere in life, in residential and commercial and infrastructure. And yet, like I said, a lot of the ways of working make it very difficult. And sometimes, people who work in jobs where you might get to work on a laptop, or you can do things on your smartphone. Picture yourself in an environment where it's a very utilitarian industry. Like, people use their hands, they're physically doing things, they're building things. It's noisy, it's dusty. They're not environments that are well suited to using the kind of technologies that are pervasive in consumer and just general business life. And so that's a big part of it. And then connectivity has historically been a problem, that most construction sites don't have Wi-Fi, have really bad cellular connection. They still use two-way radios as the primary form of communication on most commercial construction sites, which shows you the level of comms. And part of that's because even cell phone connectivity is very patchy, especially if you go towards the core of the building, like we even experience in complete buildings. So I think there are a lot of infrastructure or structural barriers to the adoption of new technologies in construction. But I definitely think that's changing. It's one of the best funded sectors from venture capital perspective in the last 3 to 5 years. The growth of money going into construction technology is off the charts. And I think as that money starts to come in, and we're seeing bigger players like Microsoft and Autodesk and others that are starting to make more acquisitions of early stage companies, I think that's representative of the fact that they are starting to make changes. And I think that there's a stat quoted that for all the building construction that's required to meet our demand as in terms of the global population, that there's not enough people and not enough infrastructure to build all of those buildings. So we have to get better. There's no other choice, and the buildings have to become more environmentally friendly because of the obvious implications of that, using different building materials and things. So I think it's early days, but it's got a lot of upside potential.
Interesting. Thank you, Matt. So we are actually all out of time today. There are a few questions left. The panelists will answer those directly with those who have asked them. Thank you all for joining us today, and I hope you found it valuable. I know I did. Very special thanks, of course, to our panelists, Rob, Matt, and Wayne. Thank you very much for joining us and for your time and sharing your expertise today. We do appreciate that. Some SCLAA events to look out for coming up is our breakfast event presented by Renee Garuso on building relationships through emotional intelligence. So that's happening on the 13th of May at the JLL head office, level 40, 101 Collins Street, Melbourne. Also a reminder that the applications for our national mentoring program closes on the 14th of May. So if you would like to be mentored by a supply chain leader, or you are a supply chain leader and like to take part in the program as a mentor, please head over to our website. And just a reminder, all the contact details for SCLAA and the presenters today are at the top of the comments box, so you'll see them there. So with that, I wish you a great day and look forward to seeing you all at an upcoming SCLAA event soon. Thank you very much. Thanks, guys.
Thank you.